Okay, welcome back. Hope you're ready to move on to Chapter 6 of Investments, Introduction to Portfolio Theory. I want to give you a slight caution or warning. This chapter involves a little bit of math, but not a whole lot of math. It's really kind of a mathematical explanation of human behavior. It's modeling, if you will, and you know that it's very difficult to model human behavior. But what we're trying to get at is a depiction or an illustration of cause and effect. There are concepts that I want you to understand, that you need to understand when it comes to returns, security returns, portfolio returns, risks, security risks and portfolio risks, correlations, how variables move together, and then we'll look at modern portfolio theory. So take a deep breath. This is not that difficult, and I'll use some examples that will help explain the concepts in the math. So with that in mind, let's start by taking a look at individual security return. The expected return of an individual stock, and this is a concept that we looked at in Chapter 1, we're going to revisit it here, jog your memory a little bit. The expected return of an individual stock is, and this we're talking about a specific percentage return, is actually or theoretically the sum of all the possible returns anticipated under a probability distribution. So harken back to Math 200, elementary statistics, and we're going to use some of the concepts from statistics. So here's the formula to get an expected return for an individual security. And of course we've got sigma here, which is sum, is the sum of the specific return times the probability of that return, of that specific return. All right, so let's take a look at an example. And again, as I just mentioned, keep in mind this is a theoretical, mathematical explanation of human behavior, and so it's not precise, it's not exact, but we're trying to explain a concept here, how things work. All right, so let's look at an example. There's a 45% likelihood that the economy will grow by 2.5% in the next calendar year, and if this happens, Walmart stock should rise by 25% over this time. So what we have is an independent variable, which is the growth rate in the economy, and a dependent variable, which is Walmart's stock price. Okay? Walmart stock price is dependent on how robust the economy is, and if the economy grows 22.5%, Walmart stock will rise 25%, and there's a 45% chance of that happening. There's a 35% chance that the economy will grow by 1.5%, a little bit slower, and if that happens, then Walmart stock should only rise about 15%. So we've got a 45% chance of 2.5% growth, 25% increase in Walmart stock, 35% chance of 1.5% growth, which would be a 15% rise in the stock price, and then a 20% chance that the economy will grow by 3.5%, okay, which is kind of an average year. If this happens, Walmart stock should rise 35%. So if you want to boil it down, we got a 45% chance of a 25% increase in Walmart, a 35% chance in a 15% increase in Walmart, and a 20% chance of a 35% increase in Walmart. Okay? So the expected return of Walmart stock is the probability times the return plus the probability times the return plus the probability times the return. So we're going to sum all of these up, and we come up with 23.5%. This is theoretically an expected return for Walmart. Does this really work in practice? Not really, but it is an explanation of a concept. All right, so please note that the probabilities, the 45%, the 35%, and the 20%, if you add them up, you get 100%. Okay? So that's our entire probability distribution there. So let's move from a specific security return to a portfolio return. The expected return of a portfolio is simply the weighted average of the expected returns of the individual securities that comprise the portfolio. So if you have an expected return for each security in the portfolio, and you have a weighting for each security in the portfolio, then you multiply the weighting of each security by the expected return of that security, sum them up, and you will get an expected return for the portfolio. Excuse me. So here's the formula. The sum of, let's see, XI, which is the proportion, this is the weighting times the expected return of the individual security. Okay? So if I take the weighting times the expected return, add them all up, and we will get the return of the portfolio. Let's make sure you get those blanks filled in there for your notes. All right, let's look at an example, and this will clarify it for you, clear it right up for you. So here we go. So we're going to take a simple two-stock portfolio. IBM is expected to provide a 20% total return. Okay, so that's the total return expected for that one stock, and that stock is 40% of the portfolio. Well, if it's a two-stock portfolio and 40% of it is IBM, how much is left? How much will the second stock comprise of the portfolio? Well, 100% minus 40% would be 60%. So the next stock is Walmart. So Walmart stock should rise 30% this year. Okay, that's the expected return and constitutes the other 60%. So we've got 40% and we've got 60%. That's 100% of our portfolio. Okay? The expected return for the portfolio is 40% times 20%, the weighting times the return plus the weighting times the return, and the expected return for our portfolio is 26%. Now, yes, I have been asked by institutional clients to give them an estimate, provide them an estimate of the expected return for the portfolio. And I went through this very same process. I looked at each security in the portfolio, the weighting of each security, the expected return for each security, and came up with an expected return for that portfolio. To be honest with you, I can't remember how close I came, but I imagine I did not come very close. It's a nice theoretical exercise. It doesn't work well in practice, but I want you to understand these concepts. All right. Let's put this example into a table. Maybe that'll clarify the concepts for you. So here we have Walmart, the expected return times the weight. IBM, the expected return times the weight. So multiply and then sum, and here's our expected return. Hopefully you can see that. All right. Now let's shift to risk. Okay, we've looked at returns. Now let's shift to risk. All right. What is risk? Let's define risk for investments. We've done this before, but it's important for you to keep this in mind. And by the way, let me also reiterate that when you are setting up an investment management relationship with a client, you don't go over return first. You go over risk first. Once you determine how much risk a client can afford to take, then you can, based on your risk exposure, your asset allocation, you can then back into return. So we should really talk about risk first. So what is risk? It's the likelihood of an unexpected outcome or uncertainty regarding an outcome. That's risk. And life is full of risk. There is no way to completely avoid risk in life or in investments. All right. In the investment world, risk is quantitatively measured as variability, volatility, movement around a mean return. So we're going to take a look at how we can actually quantitatively measure risk. All right, individual security risk. The total risk, the complete risk, and we talked about this in chapter, I believe it's chapter 7 of Managerial Finance. The total risk of an individual security or of a perfectly diversified portfolio is measured by the standard deviation, a statistic that you learned in elementary statistics math 200. All right. This statistic measures the dispersion of a set of observations around a mean observation. So we're going to set up an example, we'll set up a table, and you'll see exactly what I'm talking about. It can be used to calculate the likelihood of an unexpected outcome and also the likelihood of an expected outcome. All right, so let's look at it. So standard deviation, there's the symbol. and it's the average deviation around the mean. And here is the formula to compute standard deviation. Oh, very intimidating, very complex and impressive. Not really, not really. Let's break it down. N is the number of observations. Xi is the return is a specific observation. X is the average observation. Okay, and then we're going to take the square root of all of this. And actually, I think we're missing. Oh no, we're not. We're good. We're good. All right. So let's set this up in a table, and you're going to see just how simple this is and how obvious it becomes. So here's an example. All right. So here are the columns in our example. We have observation, the actual return percentage, the average of the returns, then the return, the actual return minus the average, and then we're going to square the return minus the average. So let's look at the observations. So we have a total of 5 observations. Okay? These are the returns of each observation. 15%, 9%, minus 3%, 12%, 7%. What is the average return? 8%. Add these up. 40 divided by the number of observations, 5, and we get an average of 8%. Okay, so let's stick that in there. Now we have 15% return less average, 15% minus 8%, 9% minus 8%, minus 3% minus 8%, so you see where I'm headed. So the return less the average, that minus that is 7, 9 minus 8 is 1, 3 minus 3 minus 8 is minus 11, and so forth. All right. Now let's find let's raise this, let's square this, okay? And so we have 7 times 7 is 49, 1 times 1 is 1, 11 minus 11 times minus 11 is 121, and really the purpose of squaring it is to get rid of the negatives. All right, then we add up the square of the return less the average, and we come up with 188. All right, we divide the 188 by the number of observations, and we get what's called the variance. Raise the variance to, or let's take the square root of the variance, and we get the standard deviation. The square root of the variance, which is raising it to the 1/2, and we get the standard deviation. And remember, the standard deviation measures the average deviation around the mean, and the higher this number is, the more volatile or risky a security is. The more this bounces around the mean, the more movement there is, the higher the average deviation is between this and this, the average difference, the riskier a security is. And so we can measure how risky a security is based on the standard deviation. Okay? So we're finished with this clip, and in the next clip we're going to put the standard deviation together with the mean and with a normal distribution probability table, and we will be able to assign a probability to an outcome. All right? It's really not that complicated, and you're going to have homework to work, and you will have to do this on an exam, but it will not be, it just won't be that complicated for you. Okay, until then, take a deep breath. You can do this. Shalom.